Integers, prime numbers, consecutive numbers, identity numbers. These are all terms that the ACT throws around. Sometimes the words number and integer can be used interchangeably, even though the word integer has a specific meaning. Now, even if this sounds familiar, I'm here to help add a little liquid cement to your already solid math foundation. Let's kick this lesson off by defining what an integer actually is. An integer is a number that isn't a fraction or a decimal. Integers can be negative, positive, or zero. They can't be fractions or decimals. Some examples of integers include 0, 1, 2, -7, 116, -2, 8, 42, and -3,000. Some numbers that aren't integers include 2/3, 1/2, -1/4, and 7/9. As you can see, if it's a fraction, it's not an integer. If it's a decimal, it's also not an integer. Numbers that aren't integers include 4.7, -1.6, and 98.6. Students are sometimes confused about the number 0, so let's go over it in a little more depth. Yes, 0 is an integer. That's a good one to remember because it comes up on the test sometimes. But you might be thinking, is 0 positive or negative, and is it odd or even? Well, 0 isn't positive or negative because it's considered the dividing line between positive and negative. This is important because sometimes a question will say something like, x is a non-negative integer. Does that mean x is positive? Not necessarily. X might also be 0. Now, let's think through this is 0 odd or even question. Every number is on the number line, and every number on the number line is either even or odd. 0 is between 1 and -1, which are both odd, so 0 must be even. You may have instinctively known that 0 was even because if you've ever looked for an address that ends in 0, it'll be on the same side of the street as all the even-numbered houses. Now let's look at an ACT problem that deals with odd and even integers. Which of the following calculations will yield an odd integer for any integer n? We can back-solve this by looking at our answer choices. If we look at A, which is 2n squared, we can eliminate it because if you multiply anything by 2, the result will always be even. Let's look at B, 5 times n squared plus 1. If we pick an even number for n, say 2, we have 5 times 2 squared plus 1. We get 5 times 4 plus 1, which is 21, an odd number. We might be tempted to choose answer B and move on to the next question, but if we try 3 for n, we get 5 times 3 squared plus 1, or 5 times 9 plus 1. This equals 45 plus 1, or 46, an even number, so B is out. Let's try C. We'll try 3 for n. So 3 times 3 squared is 3 times 9, which equals 27. Odd, so we can't eliminate it yet. If we try 2, we get 3 times 2 squared. 3 times 4 is 12, which is even. Cross out C. If we try D, n squared minus 1, we get 3 squared minus 1. 9 minus 1 is 8. Even, so we don't even have to pick another number. Cross out D2. We're getting to the end here. We've eliminated all of our choices besides E. Remember, the correct answer choice must produce an odd integer for any integer you plug in. So, it looks like we're left with E. The first part, 6n squared, is always even because it's like 2 times 3n squared. Remember, if you multiply anything by 2, the result will always be even. And if you subtract 1 from an even number, you will always get an odd number. So if 6n squared is always even, then 6n squared minus 1 must always be odd. So choice E fits the bill. Enjoy a delicious cupcake. You've earned it. Now let's talk about prime numbers, which are another special kind of number that the ACT will test you on. Prime numbers are numbers that are only divisible by 1 and themselves. For example, unlucky number 13 is prime because its only factors are 1 and 13. No other number will divide into it evenly. The ACT may ask you about the first 5 prime numbers, which are 2, 3, 5, 7, and 11. Please note that 0 and 1 are not considered prime numbers. 0 doesn't fit the bill. This is because it can be divided evenly by any number. For example, 0 divided by 2 is 0, but so is 0 divided by 10 and 0 divided by 12. The number 1 is also a unique case, and it's called an identity number. If we divide or multiply anything by 1, we get the original number. So even though 1 is only divisible by itself, it isn't prime because it has its own special name. Now let's talk about consecutive numbers. Consecutive numbers are just numbers that come one after another in order. So the first 5 consecutive positive integers are 1, 2, 3, 4, and 5. When you're looking for consecutive odd or consecutive even numbers, you just need to find the odd or even number that follows sequentially. For example, 1, 3, and 5 are all consecutive odd numbers on our list. Easy enough, right? Now that you've got a solid foundation for integers, prime numbers, identity numbers, and consecutive numbers, you're ready to catch whatever the ACT throws at you, and you'll be golden on test day. Just make sure you practice a few of the hundreds of problems available throughout this course.